Assalamualaikum and good day. I am Muhammad Zikri and I will present my progress for my project this semester titled Stellation, a living makerspace. My initial studies revolved around having to see my proposed site, which is in Punggol, Singapore, from an aerial view to understand my site intimately with the context and surrounding. As Punggol is relatively dense with residential blocks with pockets of green spaces in between, we can observe that somehow Punggol was built systematically within parcels, and it is planned with good connectivity, with majority of the building blocks are oriented slightly to the northeast. We can categorize Punggol town into two: neighborhood and pristine area that has groceries and eating houses, and town area which has larger supermarket, more food stations, MRT, LRT and bus interchange for the residents' convenience. Seeing Punggol from above, we could extract those residential blocks by coloring them in yellow to understand the context easier. By having the interconnecting roads categorized as man-made grid and act as the primary grid for Punggol development, colored in green, and the land of Punggol can be divided into parcels. Then, by extending imaginary lines from the edge of the existing buildings, in which we could try and understand it as the gaps between buildings or the organic grid, we can see from there that these imaginary lines are forming a grid system. And interestingly, this grid system created based on these imaginary lines could be rationalized as the organic movement of the residents of Punggol. The penetrations between man-made blocks, the circulation where people are heading to, could be translated into the infinite possibilities of human circulation and the future. So, what's with the grid system previously explained? This grid system is a regular and modular framework of reference lines to which the dimensions are coordinated. It should also be the flexible foundation to support a designer working in 2 or 3 dimensions. The grid can also divide a 2-dimensional or 3-dimensional space into smaller compartments, no matter the required size. And with the grid system concept in mind, I tried to start my initial research and understanding in polygons, polyhedrons, polytopes and their stellations. Stellation, in simpler and easier term, it is the process of extending polygon in 2 dimensions, polyhedron in 3 dimensions, or polytope in n dimensions to form a new figure. By having the research approach of stellations through polygons, polyhedrons and polytopes, and the understanding of these complex systems, I tried to experiment stellations on site, as I used the sense of polyhedrons as manipulative structure for this project. A research of 2D polygons pattern and 3D polyhedrons form is going to be experimented on site. By taking the grid system pattern on site explained before, I tried to take one module of the grid as a start. So this one grid module is just a mere simple square, and it is one of the basic polygons that all of us know. So by looking this square polygon from a different projection, or by taking it into 3-dimensional, we can get a regular cube. So I tried to join all 8 vertices of the regular cube to the center, and we can get 6 regular square pyramid from this regular cube. So interestingly, when this regular square pyramids is turned inside out, we could get one of the Catalan solids named rhombic dodecahedron from 6 regular square faces is now turned into 12 congruent rhombic faces. But what if stellation is applied to this Catalan solid, to this rhombic dodecahedron? What if we try to join all the vertices to the center of the solid? We could get 12 regular rhombic pyramids. And when we turn it inside out, we could get a self-intersecting polyhedron named the first stellation of rhombic dodecahedron with 48 triangular faces. So this is quite interesting, as the Catalan solid of this rhombic dodecahedron has multiple recursive forms in which the stellations could be beyond and form these complex polyhedrons. The transformation of the rhombic dodecahedron could easily be explained through these diagrams, where the regular cube is unfolded to reveal a net of 6 faces, and when the square faces is divided and extruded, we could understand that the regular square pyramids is actually a space-filling polyhedrons. In another transformation of the rhombic dodecahedron from a regular cube could be visualized through this simulation. All the 8 vertices where the 3 faces meet at the obtuse angle have these Cartesian coordinates, as what is on the slides, and when the coordinates of the 6 vertices where the 4 faces meet at their acute angles are transformed into a rhombic dodecahedron with the permutation and coordinates with parameters explained here on the slide. So, what can we experiment from the first stellation of rhombic dodecahedron? I would like to test the possibilities of grid systems that could be applied on site. A simplification of the polyhedron could be first understood by converting it into wireframes and then extract a few possible new grid systems. There's 3 possibilities of the new grid system could be obtained, as per shown in green, yellow and red modules diagram on the slide. We can see that in this experiment, the red module is tessellated to create a new 3D grid system, as this would be used for the space planning of the building programs for this project. What if we take those 3 modules, green, yellow, red, to create a new facade configuration? We can easily see that the green module could respond to the variables from horizontal plane, and the yellow module could respond to the vertical plane variables, but not the red module, as this module is just like a basic X and Y axis grid, and it could be perfect for planning and configuration of spaces. I also tried to be experimental with the green module, as I tried to tessellate the green modules. A new pattern could be obtained, and interestingly, it could be transformed into a physical wall or a facade. So when the tessellation continues at different axes, we could get a deeper facade, as this could be the possibilities of the facade to respond to the sun positions, and this could be one of the daylight strategies in this project. As for the space configuration system that will be used to connect and plan the building programs, that will be explained later, I tried to tessellate the first stellation of rhombic dodecahedron on the side, and that is following the boundary on one plane. Then I tried to create a 3D grid system by converting it to wireframes, and later I only used the red module that was previously explained. So to test the possible extent of the building massing and form, I used the surrounding side context imaginary grid, as I tried to make the building to respond to the continuity from the surroundings, In this case, I use the elevations from the south and west elevations, as it has height variations compared to the north and east elevations, in which they are just solid tall blocks viewed from my side. As when I tried to experiment with solids in computer, I realized that great and interesting visual patterns could be obtained by looking the solids from orthogonal projections, and in this case it's isometric. The first iteration that I could get is by looking at the stellations or the polygons from the frontal elevation. Also, by looking at the basic cube in isometric projection, a simple hex diagram colored in blue and yellow is formed. This could be the multiple possibilities for the patterns usable for the facade or any components for the building. And the other two visual patterns are the tessellations of the stellations of the solids. Now, there's quite a number of interesting untold stories, and one of the issues that is revolving in Punggol is the weak sense of community among the residents. A key factor that contributes to this issue is that Punggol is a new estate and the vibrancy and the kampong spirit are found lacking. Because in Singapore, street level shops and hawker centres are the general consensus of meeting place for the residents to meet and mingle. However, Punggol is still a developing estate and there's still lack of amenities between pockets of the residential blocks. So with the aim of making Punggol a more vibrant town with a hub for the residents to work and play, I would like to propose a living makerspace building typology at this proposed site, as it has the potential of being a future hotspot place for the residents. Anyway, by taking Stellation as my core concept, this living makerspace could grow exponentially, and as one of the objectives is to create a new space within Punggol that will generate a better socio-economic cycle from the involvement of Punggol residents themselves. So, why do I want to take living makerspace as my building typology? This is because living makerspace can be as a hub for the community to spend their time and gather here at the central area of Punggol, and it could maximize the economic use of this site and to avoid the urban sprawl by breaking the monotonous HDB residential building blocks around Punggol. And I will also want to take the advantage of the high density of residents. Located at Punggol downtown, which is the heart of Punggol, there's a number of means of transportation that is connecting to our side to the rest of the 11 Punggol districts, in which the MRT, LRT bus station is just a few steps away. So my proposed client is National Library Board of Singapore, and my target user, I try to cover a wide range of target users, in which the first one is to have children, specifically from lower income families, as to support early literacy. Second one is teenagers to explore their interests and skills. The third one is professionals or NGO, that could be the teacher, a seller, or suppliers. And lastly is to target the community themselves as a buyer, learner, students, or just to lepak there. My proposed building program approach is that I want to focus on the work and play. So what I meant by work and play is that work that could be by creating an economic cycle. Residents can come here to buy, learn, or teach. And for the play, I try to make it through the social cycle, instead that the residents can come here to meet, mingle, or discuss, or having a study group here. And this is because I want to promote reading, learning, information literacy to reach more than 60% of Punggol residents through this project, services, programs, and spaces. And my main program is going to be the exploration and educational. So for my research aim is to design a high energy efficiency living makerspace building through facade design as one of the daylight strategies. My first research question: what are the issues of direct daylight into a space? And the objective is to evaluate the advantages of using daylight strategies in a makerspace building typology. The second research question is: what would be the best facade configuration to achieve high energy efficiency? And the objective is to determine the design variants of external facade of a building using the Stellation concept. And the last research question is: how can an external facade contribute in form making, in designing an energy efficiency makerspace building in tropical climate? And the objective is to identify the effectiveness of external facade in form making and design process using daylight simulation software by using a new grid system. With that, thank you.